Differentiations or parametric equations. There are some mathematical functions that can be more simply expressed in the term of the third variables. For example, y equals to r sin theta, x equals to r cos theta. The r here is a constant, and the theta here will be the third variables in the functions of y and x. At any given value of theta, it will produce a pair of value of x and y, which can later be plotted into the curve of y equals to fx. This third variables of theta is known as the parameter for the two expressions for x and y, and therefore this is known as the parametric equations. These are some common parametric equations which can appear in different shapes. For example, ellipse, which looks something like this. Their parametric equations will be x equals to a cos theta, y equals to b sin theta. The parametric equations can also appear in the form of parabola, hyperparabola, and so on and so forth. Their respective parametric equations are given here. The differentiations of the parametric equations can be done by using these equations. These are the first level differentiations, and this is the second level differentiations. The differentiations can appear in the product form or in the division form, depending on the questions. For the product form, it is dy d theta to be multiplied with d theta dx. It is as if the d theta will cancel out each other, which left over it will be dy dx. In the case that you encounter dx d theta instead of d theta dx, it will appear in the division form. Dividing dy d theta and dx d theta will cancel out the d theta, which will give you dy dx. Same principles goes to the second level of differentiations. Let us try some examples for the parametric equations. It is given that the parametric equations are x equals to 5 theta minus 1, y equals to 2 theta bracket theta minus 1. The question asks us to differentiate the two terms. Differentiate x to d theta. You will get dx d theta equals to 5. And the equations for y is given here. Expand the equations and differentiate it to d theta. You will get 4 theta minus 2. Next, you need to combine the dx d theta and dy d theta. With the intentions to cancel out the d theta, it will appear in the division form. dy d theta divided by dx d theta. Rearrange the equations, you get this. Let us try another examples for the parametric equations. The equations are given y equals to 3 cos 2t, s equals to 2 sin t. Copy down the two equations. Differentiate them in accordance to the t. You will get dx dt and dy dt. You will need to combine both, and with the intentions to cancel out the dt, it shall appear in the division form. dy dt divided by dx dt. The expression here can be further simplified. Based on the formulas of trigonometry, sin 2t can be rewrite into 2 sin t cos t. Substitute it into the sin 2t. Simplify the expressions, you get this. Let us try another example. The questions asks us to determine the equations of a tangent draw at the curve at the point of x1 and y1. The equations is given here. The parametric equations are given here. x1 equals to 2t squared, y1 equals to 4t. Write down the parametric equations and derive in accordance to dt. These are the derived outcome. You need to combine the two dx dt and dy dt. With the intentions to cancel out the dt, it shall appear in the form of divisions. dy dt divided by dx dt. Simplify it, you get 1 per t. From the equation here, you have already obtained 1 per t, and the x1 and y1s are given. Substitute the respective value, you will get this equation.